Welcome to the video lecture for section 12.2. This is for MGF 1106, and my name is Jorge Gavillan. So in this section, we're going to talk about the fundamental counting principle. We're going to use slot diagrams to organize information into counting problems, and then we're going to solve counting problems with special conditions. So the fundamental counting principle, if you want to perform a series of tasks, and the first task can be done in A ways, and the second can be done in B ways, and the third can be done in C ways, and so on, and all of the tasks can be done in A times B times C all the way to N ways. So recall the information that we had from the previous lecture, Engineers Without Borders. And so they're going to select one fundraiser for each of the semesters prior to the trip. The possible fundraisers, again, online auction, air hockey tournament, themed road race, and karaoke night. And how many ways can they select the fundraisers? And so we first need to select the fundraiser for the fall, which can be done in 4 different ways. The second task is to select a different fundraiser for the spring. Now, there are 3 ways to perform this task. So the total number of ways to select the fundraiser for the year would be 4 times 3, which equals 12. Now, how many ways can 4 coins be flipped? So flipping the first coin can be done in 2 ways. Flipping the second and third and the fourth coins can also be done in one of 2 ways. So the 4 coins can be flipped in 16 ways. Now, how many ways can 3 dice, red, green, and blue, be rolled? So the first task is rolling the red die, which can be done in 6 ways. The second and the third task also can be done in 6 ways. Thus, the 3 dice can be rolled in 6 times 6 times 6 in 216 ways. Now, many restaurants in your city are participating in Restaurant Week, when they will offer a 4-course fixed price menu. Patrons will order a complete meal consisting of appetizers, soup, entree, and dessert. One restaurant offers 4 appetizer choices, 3 soup choices, 6 entree selections, and 5 desserts. So how many different complete meal choices are possible at this particular restaurant? So here we have the 4 for the appetizer, 3 for the soup, 6 for the entree, and 5 for the dessert. And so by the fundamental counting principle, there are 360 different complete meals that you can order. Now, a useful technique for solving problems involving various tasks is to draw a series of blank spaces to keep track of the number of ways to do each task. This is called a slot diagram. So in this example, we have 5 different tasks. So to open your locker at a fitness center, you must enter 5 digits in the order from 0, 1, 2, all the way through 9. And so how many different keypad patterns are possible if any digit can be used in any position and repetition of digits is allowed? The digit 0 cannot be used as the first digit, but otherwise any digit can be used in any position and repetition is allowed. Any digit can be used in any position, but repetition is not allowed. So we have 3 different examples here. So the first one, we can use any of the 10 digits for each of the 5 tasks as shown in the slot diagram. Thus we can see that there are 10 times 10 times 10 times 10 times 10 or 100,000 possible keypad patterns. So here we go, the slot diagram. Now in this situation, we only have 9 possible ways to select the first digit, so this is the slot diagram. So therefore there are 90,000 possible keypad patterns. And in C, we can use any of the 10 digits for the first number. However, because repetitions are not allowed, we only have 9 digits for the second. After 2 numbers have been chosen, there are only 8 possibilities for the third, and then there are only 7 for the fourth and 6 for the fifth number. So then this will be 10 times 9 times 8 times 7 times 6, which would be 30,240 possible keypad patterns. So here's another example. Professor Bartlett teaches an advanced cognitive psychology class of 10 students. She has a visually challenged student, Louise, who must sit in the front row next to her tutor, who's also a member of the class. If there are 6 chairs in the first row of her classroom, how many different ways can Professor Bartlett assign students to sit in the first row? So in order to use the fundamental counting principle, we must identify the separate tasks in determining the seating. So we will first consider the special condition that Louise and her tutor must sit together. So the first task, decide which 2 seats Louise and her tutor will occupy. Decide where Louise and her tutor will sit in these 2 seats, and then determine who will sit in the remaining seats. So as you can see here, as the figure shows, there are 5 ways that Louise and the tutor can sit together. Now, once we have determined which seats L and T occupy, there are 2 ways that L and T can sit within those 2 seats. L sits on either the right or the left. Now, after Louise and the tutor have been seated, we'll fill the remaining 4 seats from left to right. There are 8 students left, thus we have 8 students for the first remaining seat, 7 for the second, 6 for the third, and finally 5 for the last. So therefore, the number of ways to seat the students in the first row would be 5 times 2 times 8 times 7 times 6 times 5, which is 16,800. And that's the end of section 12.2.